Hey everyone, so this should be the last video in our how to solve systems notes. Our last method is going to be elimination. All right, so let's go ahead and get started with example 8. So the idea of elimination is we're going to use a property of systems that we haven't really talked about yet. If you have a system of equations, you can add up the two equations and you still get a result that is within the system. Right? So at any point, you can just add the two equations. Your new equation is perfectly valid. Right, now we're going to use that to our advantage because elimination means that whenever we add up the two equations, we want one of the variables to eliminate. All right, so off to the side, I'm going to put some steps over here. So first off, we're going to get opposite variables. So what do I mean by opposite variables? By opposite variables, I mean if we have a 5x, we want a negative 5x in the other system. If we have a negative 7y, we want a positive 7y in the other system. It means we want the same number, opposite signs. Right? The reason we want that is because if we add up 5x minus 5x, we get 0. Negative 7y plus 7y, we get 0. So that's what's going to let us eliminate these variables. All right. So if we look at example 8, we already have a pair of opposite variables. We have a plus y, and we have a minus y. All right, so we already have that. First step is done. All right, step 2. Add the equations. All right, so we're just going to add up, think of them as columns. All right, we're going to add up the x's, the y's, and then the numbers at the end. All right, so if we just add all of these up, x plus 4x gets us 5x. Y minus y cancels out, equals 7 plus 3 is 10. All right, so just like whenever we're doing substitution, we started with two variables, two equations, and now we are down to one variable in one equation. So this we can solve. So step 3, solve. So in this case, if we're solving, we're just going to divide both sides by 5. And we're going to get x equals 2. Now remember though, just like whenever we did substitution, getting one variable isn't enough. All right, we still need to get the second variable. So step 4, we're just going to plug back in. To solve for second variable. And then just so you have that last step, it's going to be write as an ordered pair. Just like before. All right. So we already have x equals 2. So we're going to plug it back into either one of those first two equations. It doesn't matter which one, so just pick whichever one you think looks easier. So in this case, I see smaller numbers in x and y, so I'm just going to pick that one. It really does not matter at all though. Right? So if we plug in 2 for x, we're going to get 2 plus y equals 7. All right, we're just replacing that x with 2. Now we just solve for our second variable. So subtract 2, and we get y equals 5. So our final answer is 2, 5. All right, so let's try number 9 now. So our first step was to get opposite variables. Do we already have opposite variables this time? Well, no, because the x's are both positive, so those wouldn't add up to 0. 2y and 3y, those wouldn't add up to 0. So in this case, we're going to have to make a pair of opposite variables. Right? And to do that, we're going to multiply one of these equations. All right, so let's look at the x's. They both have a hidden 1 in front of them, so they're both 1x right now, right? So what do I need for these to be opposite? Well, I need one of them to be negative. Doesn't matter which one, but as long as one of them is negative, then we have opposites, then they're going to cancel out whenever we add them up. All right? So, in order to make one of these negative, I'm just going to multiply the entire equation by -1. All right? Now remember, I just said the entire equation. So think of this as like super distributing. Absolutely everything gets the -1. Everything in the equation. So we got -x minus 2y equals -2. All right, so once we have that, we're going to stop paying attention to that very first top equation because we multiply it by something, so we have a new version of it, basically, right? So these right here that I have the blue bracket around, think of that as our new system. That's the new two equations that we're going to look at. And now we do have some opposites because x minus x. So now we can just add these up. So x minus x is 0, so that goes away. 3y minus 2y is just y equals 6 minus 2 is 4. All right, so we have our first variable solved for already. So now again, we just have to plug this in to either of the original two equations. So either of the two equations that are in typed out font. Again, doesn't matter which one. So I'm going to pick, say, that first one. So x plus 2y, which we know is 4 now, equals 2. Which means x plus 8 equals 2. And we can subtract 8 from both sides and get x equals -6. So our answer will be -6, comma 4. Because remember, it's just x, comma y. All right, let's take a look at number 10 now. So for number 10, do we have any opposite variables? No, because we have 3x and x, y and 5y. They don't even have the same numbers right now. Right? So again, we're just going to pick one of these variables and we're going to multiply the other one to get opposites. Right? So it doesn't matter. In this case, I'm just going to go for x because it's the first one I see. All right, you can do this with y as well, so there's no wrong answers, but I'm going to do it with x. So right now we have a 3x and we have an x. So what can we multiply this x by to get the opposite of 3? Well, the opposite of 3 would be negative 3, so we need to multiply by negative 3. So that's what we're going to do. We're going to multiply that whole bottom equation by negative 3. So that's going to give us negative 3x minus 15y equals positive 6. Okay. Now, just so it's a little bit easier to see the addition, I'm just going to bring that top equation down underneath it. So I'm just bringing this one right here. I'm not doing anything to it. I'm just bringing it down. That way when we add, they're right next to each other. Okay, so these are the two that we're going to add up. So if we add them up, x's cancel out. For the y's, we got negative 15y plus y gives us negative 14y equals 6 plus 8, should be positive 14. We can divide both sides by negative 14, and we get y equals negative 1. Alright, so all we gotta do now is we gotta plug it into one of those original equations and solve for x. Alright, so it doesn't matter which one we plug it into. Let's say I want to plug it into the second one this time. So x plus 5 times negative 1, because that's our y, equals negative 2. So this is going to be x minus 5 equals negative 2. Then we're just going to add 5 to both sides. We get x equals 3. So our final answer is going to be 3, comma, negative 1. All right, let's try number 11 now. All right, so we don't have any opposite variables again. So we got to pick which variable we're going to try to eliminate. Right? Now in this case, there definitely is an easier variable to do. Because if we look at the negative 5x and 3x, is there anything I can easily multiply 3 by to turn it into a 5? No, it would be a nasty fraction. Alright, so let's look at the y's. Negative 6y, negative 2y. So is there anything that I can multiply a negative 2 by to get the opposite of negative 6? Remember, the opposite of negative 6 would be a positive 6. So yeah, if we multiply this negative 2y by negative 3, then that would get us positive 6. So we're going to multiply this second equation by negative 3. That's what's going to get our opposite variables. All right, so let's go ahead and multiply. So negative 3 times 3x is negative 9x. Negative 3 times negative 2y is going to be plus 6y. Negative 3 times negative 9 is going to be positive 27. I'm just going to go ahead and erase this little scratch work out to the side, just so we have more room. Alright, now again, just like before, I'm just going to bring that top equation down. I'm not doing anything at all to it. just bringing it down so that it's easier to see what we're going to be adding up. All right, so if we add them up, negative 9x minus 5x is going to get us negative 14x. 6y minus 6y, again, that's canceling like we want, equals 27 minus 13 is 14. We can divide both sides by negative 14. We get x equals negative 1. All right, now we just plug that back into one of the original equations to get y. All right. Again, as always, it does not matter which one we plug it into. I'm going to plug it into the second one just because the numbers are smaller. All right, literally no other reason than that. Just going for smaller numbers. So it's going to be 3 times negative 1 minus 2y equals negative 9. So that's going to be negative 3 minus 2y equals negative 9. We can add 3 to both sides. So we're going to get negative 2y equals negative 6. And lastly, divide both sides by negative 2, and we get y equals 3. So our final answer is going to be negative 1, 3. Oops, don't want to cut off that equation for later. There we go. All right, example 12. So again, no variables are opposite already. So we got a 3x and a negative 2x, or a 5y and a 7y. All right, now in this case, this is kind of the worst possible scenario we can give you. This is the most work you'll have to do for one of these problems, because we can't easily turn a negative 2x into a negative 3. We can't easily turn a 5 into a 7. Right, so what this means is instead of multiplying one of the equations, we're going to have to multiply both equations by something this time. All right, so I'm going to choose to work with the x's. I'm just choosing to work with the x's because they're already opposite signs at least. One's positive, one's negative, so at least we don't have to worry about changing the signs on them. All right, all we got to do is work on getting these to be the same number. All right, now does everybody remember when we used to do LCD for fractions? Well, we can do the same thing here. So what's the smallest number that both 3 and 2 can go into? Well, that would be 6. So our goal is going to be to get both of these to be a 6, just with opposite signs, but again, the sign is already taken care of. So how do we turn a 3x into a 6x? Well, we're going to have to multiply it by 2. So we know that this top equation, we're going to be multiplying by 2. How do we turn a negative 2x into a negative 6x? Well, we're going to have to multiply it by 3. So we know this bottom equation, we're going to multiply by 3. All right, so it's the same exact idea before, or as before, just now we have to do it twice, essentially. All right, so let's go ahead and multiply that top equation by 2. So 2 times 3x is 6x. 2 times 5y is 10y, equals 2 times negative 6 is negative 12. Same thing for the bottom equation, multiply it by 3. So 3 times negative 2x will be negative 6x. 3 times 7y will be plus 21y. And 3 times 4 is going to get us 12. Now we can go ahead and add these up. So just like we wanted, 6x minus 6x cancels out. 10y plus 21y gets us 31y equals negative 12 plus 12 is 0. Divide both sides by 31, and 0 divided by anything is still 0, so y equals 0 is our first variable solved for. Now we're just going to plug it back into either of those top equations. So again, I'm just going to pick the, say, top one. So it's going to be 3x plus 5 times y, which is 0, equals negative 6. 5 times 0 is just 0, so it's just going to be 3x equals negative 6. And we can just divide both sides by 3 to get x equals negative 2. So negative 2, 0 is our answer. All right, let's go ahead and look at 13 now. So for this one, again, no opposite variables, but we can easily make them opposites. All right, so let's say we're looking at the x's. So we got 3x, negative 6x. In order to turn that 3 into a 6, we would just need to multiply by 2. So we're going to multiply that whole top equation by 2. All right, so if we do that, we're going to get 6x minus 4y equals 2. And now it's these two equations that we're looking at. So we're ready to add them up. Negative 6x plus 6x is 0. 4y minus 4y is also 0, so it's just 0 on that side. There's nothing left. Then 5 plus 2 is 7. Alright, so we're back at one of these cases. All the variables are gone. 0 equals 7 does not make sense, so it is a false statement, which means our answer will be no solution. All right, one last one. All right, again, no opposites yet. So we're gonna have to make some opposites. I assume nobody is itching to work with the fraction until you absolutely have to. So let's look at the y's instead. So to turn y into the opposite of 3y, we're just going to need to multiply it by negative 3. That way it's negative 3y and positive 3y. So the whole top equation gets multiplied by negative 3. Alright, so if we do that, negative 3 times negative 1/3 x, the 3's would just cancel, and we're left with just x. Negative 3 times y would be negative 3y, and negative 3 times 2 would be negative 6. Then we're ready to add these up. So negative x plus x is 0. 3y minus 3y is 0, so we're left with 0. Then 6 minus 6 is also 0. So in this case, 0 does equal 0. So it is a true statement. And if it's a true statement, then once again, remember, we're not talking about just linear equations, so it's not all real numbers. Our answer is infinitely many solutions. Alright guys, so sorry this video ended up being a little bit longer, but that is it for those three methods of solving systems of equations. So remember, you have graphing, substitution, and elimination. Those are the three methods of solving these two equations with two variables. Alright, and that'll do it for this video.